Right. Good morning, everyone. So today is the sixth consecutive lesson we are conducting from Sri Jayawardenapura Educational Zone, and today we are going to complete this revision paper, 100 MCQs chemistry revision paper, last 25 MCQs. After that, you might have got this paper, new paper, 2020 all batch, school diagnostic paper by the Zonal Education Office. And first we'll discuss the last 25 MCQs, that means question number 25. So we completed until question number 74 last week. The last question we discussed 74th. So covering mainly the grade 10 and 11 chemistry. Question number 75. You can see the screen. Those who had done this paper, please raise the hand. Those who have answered all 100 of the possible questions out of. How many of you had done this paper completely? Two students, 3 students raise the hand. So if you have done it, it's really good. And then you know whatever question, so you know at least what the question is. Then separately you can write down the theory behind these MCQs, because you can get similar questions in the upcoming papers. Right. Question number 75, that's related to the balancing of chemical equation. So this aluminium reacts with steam producing aluminium oxide and hydrogen. Yes, any volunteers who can give me the answer for this? Question number 75. Raise the hand, those who can give me the answer. Any volunteers? Right, Vilana, okay, so the first answer. Binula, okay. Right, very good. So Binula and Villain. So good, your answer is correct. Look at the screen, everyone. So aluminium, right hand side 2. Right, right hand side 2 aluminium. Therefore, definitely you can put 2 in front of this. When you put 2 aluminium, then you can see aluminium balance, then oxygen and hydrogen. For balancing oxygen, you have to put 3 in front of H2O, because there are 3 oxygen and aluminum oxide. Therefore, you have to put 3 in front of H2O. Right. Then hydrogen becomes 6. You have to put 3 in front of H2. So then it's become 2, 3, 3. So the answer is first one. 2, 3, 3. Answer is first one. Please raise the hand those who got the first answer before me. Question number 75. Right. Very good. There are nearly 10 raise the hand. Question number 76. According to the formula of the compound in the above equation, the valencies of aluminium, oxygen and hydrogen. So basically, if you know the group to which it belongs, you can easily tell the valency. Aluminium under group 3, therefore valency 3. Aluminium under group 3, therefore valency 3. Oxygen under group 6, therefore valency 2. Hydrogen under group 1, therefore valency 1. So you can easily get the valency from the group 1 to 4. Valency equal group number. If you want, you can copy down that using your own words in your writing book. Group 1 to 4 in the periodic table, the valency equal group number. Valency equal group number. Group 5 to 8. Group 5 to 8, valency, the common valency equal group minus the outermost group. Example, group 6. How to get the most common valency? 8 minus 6. So valency is 2. If you want, you can copy down this method the first 20 elements, you can easily remember the valency using that method. Group 1 to 4, valency equal group number, group 1 to 4. But group 5, 6, 7, 8, 5, 6, 7, 8, valency equal 8 minus group number. They can have multiple valencies also, especially group 7, 6. So I put a curly bracket for this group valency equal group 8 minus group number. So what is the valency of this group 5, 6, 7, 8? Valency equal 8 minus group number. Group number. But here the valency equal the group. Group 1 to 4, valency equal group. Valence group 1, valency 1. Group 2, valency 2. Group 3 elements, valency 3. Group 4 elements, valency 4. So here you can write group equal, valency equal. You better copy down this because I am explaining something under each MCQ. Now from this week onwards, you will get the paper 1 week before, right? Then it's easy because you can complete it. Now next week I'll be discussing most probably this paper. If there's time, I'll discuss few questions from this paper also today. Then you have enough time, to do this and keep the answers ready. Right? This is the paper we have already sent to the school's WhatsApp group. If you have not got it, you can send a request either through the WhatsApp number or you can request from your school teacher. So basically, if you don't know the valency, very difficult, like writing the chemical formula, predicting the number of bonds, and predicting the Lewis structure. So therefore, configuration, valency, and group very important. Electronic configuration. Did you all copy down this? Group 1 to 4, group equal valency. Group equal valency, group 1 to 4. Then group 5, 6, 7, 8, valency equal 8 minus group number. 8 minus group number. Okay, I'll erase this. Then, so let's move back to the question number. Question number 76. Question number 76. So I told aluminum valency 3, oxygen valency 2, and hydrogen valency 1. Hydrogen valency 1. Therefore, answer will be yes. Any volunteers? Question number 76. Those who got the answer before me. Right, very good. 3, 2, 1. Answer will be 3, 2, 1. Answer is first one. Answer is first. Question number 77. Question number 77. Magnesium oxide is formed when the magnesium burnt in air. The correct balance equation which represents this reaction. Before balancing, you better write it this using your onwards in writing. Before balancing, check whether the formula, given formulas are correct. Before balancing, you have to check whether the formula is correct. See whether formula is correct. See whether formula, chemical formula is correct before balancing. Before balancing. If formula is wrong, then no point of checking balancing. Again, I am telling this. See whether the formula is correct, chemical formula of compounds is correct before balancing. So we'll check one by one each answers whether the chemical formula of magnesium oxide is correct and oxygen is correct before balancing. Without checking the chemical formula is correct or wrong before balancing, then you will be in trouble. Sometimes you will select the wrong answer before balancing. Look at the screen, everyone. Now, magnesium, first one, why it is wrong? Okay, some of you have already given the answers through the chat. Question number 77. Now, Vilana, when you post the answer on chat, please don't forget to post the answer with the question number. So example 77 dash or 77 dot the answer. Otherwise, it's very difficult for me to read because I don't know the relevant question number, right? Okay, Raveen, Imasha, Kavindu, very good. Vilana, Binula. So question number 77, answer is fourth. Very good, excellent. Those who have already replied on chat, 77. Very good. Answer is fourth. Now it's like this. Now the other students, those who have not done this, or those who find this difficult, right? Why do we need to omit the first answer? We can omit because the formula is wrong here. Magnesium oxide, you can write MgO2. And the third one is balancing problem. The formula is correct, but it's not balanced. So why we have to omit the third answer? Because it's not balanced. Here the formula wrong. The chemical formula is wrong in the first one. Question number 2, again, magnesium will never become diatomic. That's why it's wrong. Right? Magnesium or the metals do not form diatomic molecules in the solid state because it's a metallic lattice. Right? Metals do not form diatomic molecules. Write it. If you want, you can write down this in your short notebook or in your writing book. Metals do not form diatomic molecules in the solid state or liquid phase. In the gaseous phase, there's a possibility, but not liquid phase. Question number 77, answer is fourth. The next one. Question number, I'll erase the screen. Question number 78. A metal extracted by reducing O by using carbon or carbon monoxide. This is a good question. Question number 78. Yes, any volunteers? If you only can raise the hand or you can post the answer on chat. Those have done it. Right, 78, Ravin, Imasha, right, very good. Correct. Question number 78, answer is second. Very good, Senethi, correct. So it's second answer. How come second? Right, in the activity series, so you have to recall the activity series. So the metal extraction, remember the activity series, grade 10, chapter 16. Remember the activity series in grade 10, chapter 16. Remember activity series. Otherwise, you will find this difficult to remember. So in activity series, the most reactive metals. So the example, all the group 1, if you only can copy down this, all the group 1 and group 2 metals and group 3 metals extracted by electrolysis. All the group 1, 2, 3 metals, say lithium, sodium, potassium, say beryllium, magnesium, calcium, right? Then aluminium, both. So they are extracted by which method? By electrolysis. These metals are extracted by electrolysis. The most reactive metals that are in the upper region of the activity by electrolysis. Electrolysis you will be discussing under grade 11, chapter 12, electrochemistry. Electrolysis you are done in grade 9 also, I think. Metal extraction, one application of electrolysis, metal extraction. Which metals? The most reactive metal. Then the least reactive metals like silver, platinum, gold, the bottom of the activity series, they are extracted by physical methods. They are extracted by physical methods, silver, gold, platinum. And in the middle of the activity series, say zinc, iron, they are extracted by thermal reduction using carbon or carbon monoxide. So question number 17, answer is second. Those who replied on chat, very good. Question number 79. 79th one. The main component of ore called magnetite. Magnetite is a mineral containing iron. What is magnetite? A mineral containing iron. Magnetite is a mineral containing iron. Or we call it, it's a iron ore. Sometimes in the exam they can give mineral containing iron, no ore containing iron. So it's iron ore. What is the main iron? No, hematite. But magnetite also can be used to extract iron, but mostly we use hematite. So the chemical formula of magnetite, Fe3O4. What is magnetite? Fe3O4. So what is hematite? Fe2O3. Hematite is this one. Hematite. Hematite is the first one. And magnetite is the second answer. What is magnetite? Fe3O4. So the answer is second. Those who got the answer, very good. Question number 79, answer is second. Very good, Raven, very good, correct. Your answer is correct. Question number 80, metal extracted by electrolysis. You can write by electrolysis, you can write the most reactive metal or the metals in the upper region of the activity series. Metals in the upper region of the activity series extracted by this method. So I'll highlight here by electrolysis. In front of that we can put a dash and write by electrolysis which metals? Group 1, group 2, group 3 metals. In your O-level periodic table. Or you can write most reactive metals. Or you can write most reactive metals. Group 1 metals are the most reactive metals out of all the groups. Group 1. Most reactive metals. So you can write metals in the upper region of the activity series. Upper part of the activity series. Metals in the upper part of the activity series. Right. This aluminium. All of this, which metal is found in the activity series? Aluminium. Aluminium. Question number 81. What happens when zinc is placed in copper 2 sulfate solution? Now this is actually, again you need that, remember, you have to remember, other than the periodic table, you get many questions from chemistry related to the activity series. If you don't know the first the 14 metals in the activity series, you will find this very difficult to answer the questions under this then single displacement reaction, electrolysis. Okay, question number 81, some students gave the second answer. So Vilana Sitlini, third answer, and Kavindu, second answer. What about the others? Any other volunteers? Right. Question number 81, you better make a small sketch this diagram. When you add copper sulfate, it's blue. Copper 2 sulfate means because copper can form Cu plus ion and Cu prick ion. So copper 1 means Cu plus. Copper 2 means it's Cu2 plus. That's why don't worry about this copper 2. That is the standard method of writing when there's multiple valency or multiple charge. So copper 2 means, within bracket, Roman number 2 means is Cu2 plus, Cu prick. So Benedict solution contain Cu prick ion, copper sulfate Cu prick. So Cu plus is Cu plus. So this is Cu2 plus, that is copper sulfate solution, which is blue. So what happens now when you add zinc to this copper sulfate solution? So this is copper sulfate. What is the color here? Blue. So this is a very important. They once in the oral paper they gave this under structure essay also. This is a blue solution and is CuSO4. So what happens now when you add zinc? Zinc is more reactive than copper. Zinc is above copper in the activity series. Therefore, what happened? Copper get displaced by zinc. Copper get displaced by zinc, and copper is deposited or displaced by zinc, and copper will be deposited to the bottom as reddish brown. Copper will be deposited as reddish brown. So copper deposits, and the position of copper, the copper is replaced by zinc, then copper sulfate becoming zinc sulfate. You can make a small sketch this diagram because there are a lot of observations here, and this reaction is single displacement reaction. You can remember the oxidation reduction. This is a very good question they could ask in the exam. So what happens? Zinc become zinc sulfate since because zinc is more reactive than copper, because copper is below zinc in the activity series. So this becomes zinc sulfate, and copper is deposited, copper is displaced. This is what happened. So we can now this is colorless, clear solution. Zinc sulfate solution is colorless. That means blue solution become pale. Copper sulfate is blue, but zinc sulfate is not colored solution. So you can write the equation now. What happens when you add zinc to copper sulfate solution? Since zinc is above copper in the activity, zinc is more reactive than copper. Therefore, zinc combined with sulfate forming zinc sulfate, and copper get displaced. That is called what reaction? This is known as single displacement reaction. This reaction is called single displacement reaction. Not only the answer for this question, I want you to recall uh, everything related to this question. Then only if you get a similar question again in the oral paper, you will you can do it well with confidence. So what is this reaction called? Single displacement reaction. Single displacement reaction. Write it, the reaction, everyone. Single displacement. Therefore, what is the main requirement for the single displacement reaction? The metal added should be more reactive than the one in the solution. Again, I'll repeat. The metal added has to be more reactive than the one in the solution. So actually what happens during this reaction? There are two reactions. So this is the overall reaction. This is the overall reaction. But we can split this into what? Zinc get oxidized. What happened? Zinc atoms lose electrons and become Zn2 plus 2 electrons. So this reaction is known as oxidation. What is reaction? Oxidation. What is oxidation? Losing of electrons. Grade 10 you don't learn oxidation, but grade 11 you need. Because this is like grade 10 and 11 chemistry combined. Grade 10 single displacement reaction. Grade 10 activity series. But oxidation reduction you learn in grade 11 chemistry. Grade 11 chemistry. So when someone loses electron, the electrons loss and gain must be balanced. If someone loses electron, there must be someone to gain it. So therefore, who gain electron? Cu2 plus. So what is actually, even though we write copper sulfate, what is available in the solution? Cu2 plus and SO4 2 minus. Copper sulfate means it consists of what? Cu2 plus, because it completely dissolved and it gets separated into copper ions, positive ions and negative ions. Copper sulfate solution, no copper sulfate. It contains only Cu2 plus and SO4 2 minus. It doesn't remain as one unit, copper sulfate in the solution, because same as sodium chloride. If you put sodium chloride into water, no NaCl in water, it contains only Na plus and Cl minus. Imagine you put HCl into water, hydrochloric acid, no HCl molecules in water, right? In the solution. So it contains only hydrogen ions, H plus and chloride ions. That also you have to understand. So that's why here zinc atoms lose electron and Zn2 plus. I'll highlight this green. That is called oxidation. In oxidation, the charge increase. Zinc is neutral and neutral atom become positive charge. The charge increases from 0 to plus 2. Or in O-level chemistry, we define this as what? Removal of electrons by an atom or ion called oxidation. Again, I'll repeat. What is oxidation? Removal of electron by an atom or ion. Now, what is reduction? Look at the screen. Reduction will be gaining of electrons. Electrons loss and gain must be balanced. So both these together called redox. Reduction and oxidation is a simultaneous process. If there's oxidation, there will be a reduction. If there's reduction, there will be oxidation. Only oxidation not possible, only reduction not possible. Therefore, such reactions are called redox reactions. Because in your O-level chemistry, you learn single displacement, double displacement, combination, decomposition reactions. But other than those four types of reaction, there are many different types of reactions in chemistry. I'll give one example here: oxidation half reaction, reduction half reaction. Or when you combine both these, we call it redox reactions. REDOX, redox. In addition, there are precipitation reactions, there are exothermic reactions, endothermic reactions, neutralization reactions. There are many reaction types in chemistry. Out of them, the endothermic, exothermic and neutralization you will get in grade 11 chemistry. So single, double and combination decomposition grade 10. Right? Exothermic, endothermic and neutralization reaction in grade 11. So what happens in reduction? Cu2 plus gain 2 electrons and become Cu. So copper ions get reduced, zinc atoms get oxidized. How many electrons lost by zinc? 2 electrons. Electrons lost by zinc gained by whom? Copper ions in the solution. Again, I'll repeat. If you have this using onwards, zinc oxidize. Zinc oxidize by losing electrons. Zinc oxidizes by losing electrons. Losing electrons. And copper gain those electrons lost by zinc and undergo reduction. Cu2 plus, not pure copper, who get reduced? Cu2 plus. Right? It is very important when you come to grade 11 chemistry. This will be very useful. Cu2 plus gain electrons and undergo reduction. So I'll write copper reduced parallel to the previous statement. I write copper reduces. Copper reduces. Sometimes you might be wondering why this losing is plus and losing is plus and gaining is minus. But here reduction is gaining, not losing. So because actually the meaning is not losing and gain in the reduction and oxidation here. Reduction means receiving electrons and charge decreases from 2 plus to 0. Copper ions reduces by gaining electrons. Gaining electrons. Those who are planning to do A-level bioscience and maxo physical science, I mean the bioscience or physical science, that's very important to understand this concept. You need this again in A-level also. So now you can easily understand the answer. Who get oxidized? Copper. Atoms or zinc atoms. Zinc atoms oxidize, right? Copper atoms, no oxidation. Copper atoms get copper ions get reduced. No copper atoms in the solution. Copper ions. Again, I'll repeat. In the solution, no copper atoms. Copper ions. Copper ions reduced. You add in zinc rod, that is zinc plate that contains zinc atoms. So zinc atoms get oxidized. So who can give me the correct answer now? Yes. Question number 81. Any volunteers? Raise the hand. At least now you can look. Give me the answer. I gave everything possible for this question. Not only the answer for this question, even any other question related to this. What type of reaction? Single displacement. Observation: blue solution become colorless, and copper reddish brown copper deposit. Blue solution. What are the 3 observations? If you get this in the structure, this is what I'm going to write. 3 observations of this reaction. Yes, Imansha, what is the answer?
Second answer.
Very good. Second answer, right? Okay. Some of you have replied on chat. Yeah, Vilana answer is second. Now Binula answer is not third. Okay, so because zinc is not getting displaced, who is getting displaced? Vilana, not Vilana. Sorry, Binula. Binula, right? Yeah. Who is getting displaced here? Copper. By whom? By zinc. Therefore, the answer is not third. Okay, so who get displaced? Copper, not zinc. Vilana, right? Binula, sorry. Then others are correct, right? Okay, Sitlini correct. Yeah, good. And who else replied on chat? Kavidu correct, very good. Right. Question number 81. So this is a good question. They can ask oral paper also the questions related to this. So you can put a star with the red pen for this question. This MCQ is important for upcoming papers. Put a star for this. So what are the things they could ask here? Observations they can ask. Reactions they can ask you to write. And you can write the, you can compare the position or the metals in the activity series by which one is above. Zinc is above. That's why copper has to leave when zinc is added. So you can compare the reactivity of metals. Then you can learn the type of reaction, single displacement. And whether you can decide whether this reaction you can write, but whether this reaction is possible or not. That also you can predict. What happens if you do the other way around? If you add copper to zinc sulfate, no change. Copper is less reactive. Copper cannot displace zinc. If you do this the other way around, keep in copper sulfate in the solution and add in, keep in zinc sulfate in the solution and add in copper. Zinc sulfate in the solution and add in copper. No changes. No reaction will take place. You can write the reaction, but it's not going to happen in the real world. Understood? Okay. Then, so oxidation and reduction, new terms you learn here. What is oxidation? Losing of electrons. Reduction is gaining of electrons. Who get oxidized easily? The metals at the upper part of the activity series get oxidized easily. Metals at the lower part of the activity series get reduced easily. When you are given 2 metals, you should know who get oxidized, who get reduced. Right? Easily. You can predict by the position of the metals. If you know the position of the metals in the activity series. Okay, I'll erase the screen. Question number 81, I explain in detail since it is important not only for the MCQs, even essay type questions in the paper. Now question number 82. Look at the screen. Question number 82. What are the materials for the electrodes in the extraction of aluminium? Actually, this question, aluminium extraction. Yeah, I'll make a small change. Extraction of sodium. I'll make it extraction of sodium. Make it sodium because aluminium extraction is not there in syllabus now. Sodium extraction is there in the grade 11 chemistry. For the sodium extraction, we use graphite anode and steel cathode. What is used? Graphite anode and steel cathode. I don't know if they have done electrolysis, electrochemistry, the chapter 12, grade 11. So therefore, no need to worry about that if we have not done. Graphite anode and steel cathode, the materials used for the sodium extraction by down cell. Question number 83. Which substance remove impurities from the iron ore in blast furnace? Yes, that's a good question. Who can give me the answer? This is from grade 10. Question number 83 from grade 10. Any volunteers? Any volunteers? Who can give me the answer for this? 83. Yes? I got the answers from Ravin, Vilana. What about the others? Okay, blast furnace. The answer is limestone. Answer is limestone. To remove impurities, we use limestone. Question number 83, answer is second. Very good. Those who have replied on chat. Imasha also correct. So this is what happened. Look at the screen, everyone. Calcium carbonate you can obtain from the corals in the sea. It's get decomposed in the furnace, generating carbon dioxide gas and calcium oxide. Look at the screen, everyone. CO2. So this CO2 also useful. Why? This CO2 can be used to make carbon monoxide. CO2 can contribute to the formation of carbon monoxide. CO2 can combine with carbon to form carbon monoxide. So that carbon monoxide can be used to make iron from hematite. So Fe2O3 hematite, carbon monoxide can pull away oxygen from hematite. Then iron will be left, carbon monoxide become carbon dioxide. This is the main reaction. I didn't balance it. This is the main reaction which release iron in the liquid form that happens at high temperature. Liquid or molten iron, sometimes we call it pig iron. So it is produced in the liquid form because of high temperature. Now the next problem, what will happen to calcium oxide? So now you understood the importance of carbon dioxide. Carbon dioxide to make carbon monoxide. Carbon monoxide removes oxygen from hematite, giving us the main product iron. So what will happen to the calcium oxide? This is what happened to calcium oxide. Calcium oxide combines with the impurities. So calcium carbonate, both the products. What are the two products of calcium carbonate decomposition? Calcium oxide and carbon dioxide. Carbon dioxide is used up for this. And then calcium oxide to remove impurities. What are the two possible impurities present or mixed with the hematite? SiO2, silicon dioxide. Then what happened? It become calcium silicate, CaSiO3, calcium silicate. The other one, aluminium oxide, Al2O3. Then you get calcium aluminate. What do you get? Calcium aluminate, CaAl2O4. So calcium, so this is also called slag. What is called slag? Therefore, I will highlight the two impurities. What are the two impurities here? Silicon dioxide and alumina. Silicon and alumina. Who is going to remove this? Calcium oxide. Calcium oxide come from calcium carbonate. Calcium oxide come from calcium carbonate. That's why we select the answer calcium carbonate or limestone. So this is also called limestone if you don't know right the common name. And this is called quicklime. Calcium oxide is called what? Quicklime. So these are the 5 reactions that you have to remember under the iron extraction grade 10 blast furnace chapter 16, because you can get essay type questions from this section in the O-level paper. Not only that, they can ask even chemical calculation also. So they can ask how many moles of iron, or how many kilos of iron, how many grams of iron produced from this much of hematite. Then you should know the chemical calculation also they can test here. So what is the agent of this? Carbon monoxide act as what agent? Reducing agent. Carbon monoxide act as what agent? Reducing agent. Reducing agent removes oxygen from hematite. Reducing agent. This is the agent which makes hematite to reduce. What is reduction? Okay, reduction is removal of oxygen. If someone combine with oxygen, oxidation. If you write here, combining oxygen with oxygen is oxidation. Losing oxygen is what? Gaining oxygen is oxidation. That way also you can gain in oxygen atom. If someone combine with oxygen, that is called oxidation. If someone lose oxygen, that is called reduction. Losing of oxygen is called reduction. Losing oxygen atom called reduction. Therefore, who get reduced here? Look at the screen again. This reaction, hematite is getting reduced, so undergoing reduction, oxidation, reduction, right? Hematite lose oxygen. Hematite lose oxygen and undergoes reduction. But what is the agent which makes hematite to reduce? Carbon monoxide. Again, I'll look at the screen. Carbon monoxide is the agent which makes hematite to reduce. That's why we call it reducing agent. Reducing agent is not undergoing reduction. Reducing agent oxidize. Reducing agent combine with oxygen, but it makes the other guy to reduce. Reducing agent makes the other guys to reduce. Other guys means hematite. Therefore, actually, hematite acts as oxidizing agent. Hematite makes the carbon monoxide to oxidize. So here, look at here, carbon monoxide combine with oxygen and become carbon dioxide. Carbon monoxide oxidize because it combines with oxygen, but indirectly it is the agent which makes the other guy reduce. That's why we call it reducing agent. Therefore, reducing agent oxidize by gaining oxygen. So the reducing agent, the name, not just because of its undergoing reduction, it makes the other substance to reduce. Who make the other substance or hematite to reduce? Carbon monoxide. That's why we call it thermal reduction by carbon monoxide. What is this method of extracting iron called? Thermal reduction. Thermal means heat. Reduction is removal of oxygen. From whom? From hematite. To get pure iron, you have to remove oxygen from hematite. And one more thing, you can easily balance it. To remove one oxygen, carbon monoxide can combine with oxygen. Carbon monoxide can combine with maximum one oxygen. But how many oxygen atoms are there in hematite? 3 oxygen. To remove 3 oxygen, you need 3 carbon monoxide. Then it becomes 3 carbon dioxide. Look at here. Carbon monoxide can combine with 1 oxygen. Then it becomes CO2. This reaction should occur 3 times. Again, because there are 3 oxygen atoms in hematite, all 3 should be removed. Then this reaction occurs 3 times. That's why we call it 3CO. 3CO and become 3CO2. But this oxygen comes from hematite. These 3 oxygen atoms come from hematite. To remove 3 oxygen atoms, you need 3 carbon monoxide because 1 carbon monoxide can remove only 1 oxygen. Therefore, I don't want you to memorize these things. It's logically, you can remember all this logically. So, no need to memorize everything one by one. So, it's so difficult. Right. So, again, some MCQs I am going to explain bit in detail because it's important for coming for essays. So, this is one such question. So, therefore, you can put a star for this. Question number 83. Okay, shall I read the screen? Anyone still copy now? Raise the hand. Anyone still copy now? Raise the hand. Done, right? So 5 reactions we have to remember. 3 reactions involved with the removal of impurities. Yeah? 3 reactions linked with the removal of impurities, but the other 2 reactions linked with the removal of oxygen from hematite. But the problem is, unfortunately, we don't manufacture pure iron. We import iron, sodium. Most of the metals we import to Sri Lanka. Even chemicals like that to make battery acid, you need sulfuric. We import. We don't have that industry in Sri Lanka. Then to make soap, we need caustic soda, sodium hydroxide. That also we import. So that's why the raw materials we are importing, even though we manufacture some goods or the chemical products in Sri Lanka. Right. Question number 84. I'll erase the screen. 84. Yes, any volunteers? Descent in order of reactivity. What is the meaning of descent in order of reactivity? Descent in means highest to lowest. Please highlight if you want. Descent in means highest to lowest. Highest to lowest. That is most reactive to least reactive. Any volunteers who can give me the answer for this? Any volunteers? Any volunteers? Right, very good. Question number 84. Ravin, very good, correct. What about the others? Villana, not third answer. Villana answer is not 3. Because sodium is more reactive than aluminium, sodium cannot come last. Highest to lowest. Citlini answer can't be second. Refer the activity series again, I am telling you. To find the descent in order of reactivity, you should remember the 14 metals of the activity series. Refer activity series. Refer the activity series. Look at the screen, everyone. Answer is first. Those who get the first answer is really good. Seniti, Kavita, very good. Your answer is correct. Ravi, correct. Well done. Answer is first one: zinc, iron, mercury, gold. Highest to least reactive. Third answer you can't take because sodium last. Fourth answer you can't take. Zinc has come after iron. Zinc is above iron. Zinc is more reactive than iron. That's why we have to omit the fourth answer. Second answer, the problem again, zinc has come before. I mean lead. Lead is less reactive than zinc. That's why. Right. Question number 85. Hematite. Chemical formula of hematite. That's a very simple question. Anyone can easily get the answer for this. Yes. Any volunteers? Answer for the hematite chemical formula. That is the most common iron ore used in the extraction of iron. Very good. 85. Imasha correct. Binula, okay, good. Avin correct. Sitleni correct. Lakindu correct, very good. Answer is second. Question number 86. Does not appear in the action of rusting. Rusting actually again is grade 11 chemistry. Rusting, what happens? Iron get oxidized. In rusting, what happens? Iron get oxidized. Iron become Fe2 plus in rusting. When iron oxidize, the electrons are lost, given out. Then electrons loss and gain must be balanced. Who gain those electrons? Oxygen and water. Oxygen and water receive these electrons, 4 electrons, and become 4 OH minus. So these are the two reactions that occurs during the rusting of iron. First reaction is oxidation. Second reaction is reduction. Sir, redox process or redox reaction. What is reduction? Gaining of electron. What is oxidation? Losing of electrons. That's why now by you might have learned water and oxygen necessary for rusting. Oxygen and moisture necessary for rusting. Why? For the reduction reaction to take place, both oxygen and moisture required. Without oxygen and moisture, if without one substance out of these two, either no need both. If one of these missing, oxygen or water, no rusting. Why? Without reduction, no oxidation. What is reduction? Receiving of electrons. What is oxidation? Losing of electrons. Receiving of electron, reduction, losing of electron, oxidation. Therefore, if there's no one to lose electron, water and oxygen will not reduce. Or without reduction, no oxidation. If you stop water or oxygen come in contact with the metal or the nail iron, then no chance for the reduction. Without reduction, no chance for the oxidation. Without oxidation, no rusting. Again, I'll repeat. If oxygen, no water. If one of these missing, no reduction. Without reduction, no oxidation. Without oxidation, no rusting. That's why we apply various coating, paint, grease, nickel, we apply lubricant, various things to protect metal from rusting or iron. Galvanizing, right? Galvanizing, then making alloys, converting the iron into alloys, iron alloys. So therefore, rusting is an economical loss. Due to rusting, there will be an economical loss because you have to again replace them, or you have to paint them, you have to clean them. So it's an economical loss for the country. Even vehicles, train, railway line, flyover, many metallic constructions get eroded due to the rusting of iron. Therefore, rusting is an electrochemical process. Corrosion is an electrochemical process. That's why it's taught under chemistry. Okay, understood? So, which reaction is not possible here? Very easy. Rusting, third reaction is related to the blast furnace. Look at here. Third reaction is related to the blast furnace iron extraction. That is not related to the rusting. If you don't know exactly the answer, you can, start with the ones you already know. You know the third reaction. That doesn't occur in the rusting. That happens in the iron extraction. This is in the blast furnace. Blast furnace. Right. But first reaction, oxidation, yes. Second reduction, reduction, yes. The last one is what? Then that is the last stage of rusting. This is called brown rust, hydrated iron oxide. Then it's too late. You can recover iron. You have to just remove the rust and clean it. So therefore, rustin you learn in grade 11 chemistry, but I gave the theory behind this so that you will understand this question, even though you might have not done grade 11 chemistry 12th lesson yet. With this knowledge, you can understand what is rustin. Rustin is what? Iron getting oxidized. What is oxidized? Iron lose electron and become ferrous, Fe2 plus. So that when iron lose electron, electrons lost should be gained by someone who gain those electron, oxygen and water, becoming OH minus, hydroxide ion. So actually what happened then after that, this Fe2 plus, ferrous and OH minus combine. Product of these two reactions combine forming ferrous hydroxide, FeOH twice. That's what I have given in the last reaction, last answer, fourth one in the question number 86. But anyway, no need up to that extent to get the answer for this question. You will learn this again under chapter 12 electrochemistry grade 11. Right. Question number 87. Substance that decrease the rate of rusting of iron. That is actually acids increase. Ne? If you dip an iron in vinegar or lemon, the rusting increases. Water also, rusting is necessary water. Then salts, metallic, maybe vehicles, so in the coastal area, even air AC outdoor unit get corroded much faster because of the saltiness. Salts increases the rusting. Right? Acids increases the rate of rusting, but bases reduces the rate of rusting. Base, when there's a base already, formation of OH minus suppress. You understand what I'm saying? If you have already the product that is going to be formed already there, then that product is not going to form fast. That means reduction is not going to happen fast. That means reduction slow down. If you slow down the reduction, oxidation also slow down. If oxidation slow down, rusting decrease. Again, I'll repeat. If you keep sodium hydroxide around the nail, so this is not going to form fast because OH is already there from outside. Then reduction slow down. If the reduction decrease, oxidation also decrease, because oxidation and reduction is simultaneous process. Oxidation and reduction simultaneous process. With only oxidation not possible, only reduction not possible. That means if someone lose electron, there must be someone to gain it. That means electrons loss and gain must be balanced. These reactions are called redox reactions, oxidation reduction equations. Right. Question number 87 answer is first one, bases or any hydroxide is a base, lithium hydroxide, potassium hydroxide, even lime water, that is calcium hydroxide. It reduces the rate of rust in the bases or basic solutions. Right. Question number 88. I'll read the screen. 88. Which of the following gives pink indication after adding phenolphthalein? After adding phenolphthalein. Question number 88. Yes, any volunteers who can give me the answer for the 88? Phenolphthalein is an indicator. Grade 11 chapter 7. Grade 11 chapter 7. Phenolphthalein, I don't know if they had done in grade. So what is the original color of phenolphthalein? Colorless. What is the original color of phenolphthalein? Colorless. Colorless. So what happens in the presence of OH minus or bases or hydroxide ion? Colorless is a clear solution, phenolphthalein indicator. In the presence of OH minus, it turns into pink. It turns pink. In the presence of OH minus, this turns pink. Is that clear? Phenolphthalein turns pink in the presence of OH minus. OH minus can come from what? Even the rustin, that O2 plus H2O become OH minus. So therefore rustin, whether around the ionel, if you get pink coloration, that means the reduction reaction has occurred. If the reduction has occurred, definitely the oxidation also has occurred, right? So therefore we can predict whether the ion has initiated, the rustin has started or not. We can check by using phenolphthalein. Not only that, if you put piece of magnesium into water, what is formed? Or if you put piece of sodium into water, what is formed? Sodium hydroxide. If you put magnesium into hot water, what is formed? Magnesium hydroxide. Then you can easily identify the product form by putting drop of phenolphthalein. Look at the screen, everyone. If you put a piece of sodium into water, what is from sodium hydroxide? Here is H2O. These two react forming sodium hydroxide. If you put magnesium into hot water, what is forming? Magnesium hydroxide. So both these are basic substances, alkali, basic. This is also basic. So how to identify whether these things is present in or not in the solution after the reaction? By adding a drop of phenolphthalein. If the solution turns pink, that means these two substances they are present in the solution, that means reaction has happened. Because reaction not visible to unnaked eye, the electrons and ions and all this not visible. Color change, yes. Evolving of a gas, yes. But we don't really see the electrons going out, in and out. During the reactions, electrons participate. From atom to the other atom, electrons are transferring to external one or external conductor if in case of electrochemistry. Okay, so what is the use of pinophthalene? To identify basic solution. Actually, I don't know how many of you have seen the Bulaktita Hunu. Chewing the beetle. Chewing with beetle, we use Arikanat Puak. And we use Bulaktita Hunu, that is a base. What the color? When you put Arikanat water into a lime water or basic solution, it turns pink or like reddish color. So it's an indicator. It's an indicator. If you take turmeric or the kahakudu in your kitchen, that is an indicator. So if you put some acid into turmeric powder, it returns red. It's yellow coloration in the basic media. So there are natural indicators also. Natural indicators. Therefore, pinophthalene, a colorless indicator to identify the presence of OH minus or hydroxide ion in a solution or in any other compound. Question number 89. I'll read the screen. So what is the answer for this pink coloration? What is the hydroxide? What is the base given here? Question number 88. Answer is potassium hydroxide. And the other most important is basic solutions can combine with acidic gas like CO2. They can combine with acidic gases like CO2. That's why we use respiration experiment in grade 10 potassium hydroxide, sodium hydroxide, even lime water, all these bases, basic solutions. Therefore, acidic gases can be dissolved in basic solution. Basic solution. So in your bedroom, if you have a water basin with sodium hydroxide or sodium hydroxide in a can or in a container exposed to the atmosphere, then what happen? CO2 getting absorbed to that. Therefore, potassium hydroxide, sodium hydroxide, calcium hydroxide or lime water, they can absorb acidic gases like CO2 because acids and base react. Those things also bit important. Right, question number 89. I'll read the screen. Actually, not the answer for this question. You should learn something new from each MCQ. Then only you will perform very well in the exam. Right, very good. The third answer, question number 88. Ravin, Anupme, very good. When you're posting the answer, Lakindu, Mahasha, Fernando, please put the question number also. Otherwise, it's difficult for me to figure out which question. Right. Question number 89. Cathodic protection. This is also a very interesting question. Cathodic protection. So there's something called anode and cathode. Anode is the place where the electrons are lost. Anode is the place where the electrons are lost. Cathode is the place where the electrons are gained. Cathodic protection, that means the place where the electrons get protected. So look at the screen, everyone. If you take an iron nail, if you want to prevent iron from rusting, you can attach a metal which is more reactive than iron. Then that metal acts as a bodyguard and protect iron from rusting. For example, I'll use zinc here. Look at the screen, everyone. So I want to protect iron from rusting, iron nail. So I keep iron nail in contact with zinc. This is again grade 11 chemistry. Okay, sometime you might have not done, but anyway, I'll explain and do it. So the last 10 MCQs will finish it, then this paper is over, then we can start the new paper. Zinc is more reactive than iron. Again, to cathodic protection or anodic protection or rusting, electrochemistry, electrochemical cells, you need to remember the grade 10 activities here. When you are given two metals, you should know who is more reactive. The most reactive metal is zinc, that act as anode. Look at, copy down everyone in the writing book. In a pair of metal, the most reactive metal act as anode. Zinc oxidize, forming Zn2+ and lose electrons. So this is called what reaction? Oxidation. Therefore, zinc get oxidize. Zinc oxidize. And zinc act as anode. Why? It lose electron. The one who lose electrons act as anode. Why zinc lose electron? Because zinc is more reactive. Write everything. Number one, zinc is more reactive. Than whom? Than iron. Zinc is above iron in the activity series. Zinc is above iron in the activity series. That is the first thing you have to remember when you look at these two metals. Therefore, number two, zinc oxidize and acting as anode, and zinc lose electrons. Zinc lose electron. Then who gained these electrons? Electrons loss and gain must be balanced, and electrons cannot be left in the atmosphere. So these electrons travel through the iron rod, and then near iron nail, oxygen and water gain these electrons and become what? OH minus. OH minus. So this is the other reaction. What are the two reactions here? Zinc oxidize, zinc getting dissolved, or zinc sacrifice by itself to protect iron from rusting. Zinc sacrifice by itself to protect iron from rusting. That is why zinc is called sacrificing metal. Zinc act as sacrificing metal. That this method of protecting iron from rusting called what? Galvanizing. What is this process called? Galvanizing. Galvanizing. Have you all seen in the GI butter, GI tubes? That is called galvanized iron. GI box bar, GI bar. So the Satellin and all, they use this. GI means galvanized iron, so that they don't get corroded. Sometimes you get concrete and all, and iron nail also you can have galvanized one. Even gutters, vahipili, you can have barbed wires, katukambi for the fences, galvanized. If you take the bucket used to draw water from a well, we call it panittu, that is galvanized. Why it's galvanized? What is used for the galvanizing? Zinc. Why zinc is used? Zinc is more reactive than iron. Therefore, zinc act as a sacrificing metal and protect iron from rusting. So when zinc become anode, who will become cathode? When zinc become anode, what is the other metal which act as cathode? When zinc act as anode, iron act as cathode. That is why iron gets protected as the cathode. Again, I'll repeat. Iron gets protected as the cathode. That's why we call it what protection? Cathodic protection. Understood? That is called cathodic protection. Cathodic protection. So right, everyone, iron gets protected as cathode. Therefore, we call it what protection? Cathodic protection. Fe gets protected as cathode, therefore we call it cathodic protection. Iron gets protected as cathode. Iron gets protected as cathode, therefore it is called cathodic protection. Iron gets protected as cathode. But near iron nail, moisture and the oxygen are the two enemies. They will receive the electrons lost by the zinc. Zinc lose electron, water and oxygen gain electron. If water and oxygen is not around the nail, there's no one to receive electron. A pure metal will never receive electron. This is very, very important to understand. A pure metal, copper will never become Cu minus. Iron will never become Fe minus. A pure metal will never become negatively charged. Sodium will never become Na minus. Potassium will never become a metal, always going to be positively charged. A metal will never get negatively charged. That's why the metal iron cannot gain electrons. The electrons lost by zinc must be gained by someone. Pure iron can't do it. That's why the two enemies, oxygen and moisture, helps to make the reduction possible. Oxygen and water. That's why oxygen and moisture act as enemies for the metals, because they are waiting to gain electrons from the metal. When oxygen and moisture gain electron, metal has to lose electron. Then that means if metal lose electron, metal get oxidized. Metal is getting used up. Metal is getting dissolved. That is called corrosion. That's why we apply paint, grease. Why? To prevent the enemies reaching near the nail. Or the metal. Painting, grease, applying, a protective layer like coating, like nickel, biscuit tin, cement tin. There's a coating now. That is the protective layer. Or else you have to galvanize it, like the GI, panittu and all this stuff. Barbed wire, so yeah. Katukami. Yeah. Now, zinc actually it's above iron in the activity series. That otherwise this is not possible. Is there any use of keeping a gold bracelet or chain made of gold in contact with the iron nail? They cannot act as bodyguard. They are very less reactive. They cannot protect iron from rusting. Right? Therefore, in the activity series, the metals above iron should be used for the cathodic protection. In the activity series, the metals more reactive than iron should be used for the cathodic protection. So now you can understand the answer for this question. Could not be used for the cathodic protection. The metals above iron can be used. The metals below iron cannot be used. Again, children, activity series grade 10, don't sit this time all level if you don't know the grade 10 chapter 16 activity series, because there are questions related to grade 10 chemistry as well as grade 11 chemistry related to the activity series in grade 10. Very important. First thing, you have to study the periodic table for the first 20 elements. Number two, the second thing you have to remember, grade 10 activity series, grade 10 chapter 16, from most reactive to least reactive, you have to remember them in correct order, correct sequence. So the answer here, answer is 3. Cathodic protection, you can't use tin. Cathodic protection, you can't use tin. What is SN? SN is tin. If you are using tin like a wall, you have to completely cover the nail with tin. Then it's like a barrier, right? But keeping in contact with the nail, iron nail, tin is not going to work. Zinc can, bodyguard. It's like a soldier with a weapon near you. No need to make a wall around you to protect you. So keeping a soldier with a weapon enough, no one will reach you. So this zinc like a bodyguard for the iron. But if someone asks, can't we use lithium, sodium, potassium? They are not suitable. Why? They are very violent. They can't wait until the enemies come. They will go and fight with the other guys and getting used up, getting destroyed. Sodium, potassium cannot be used for this, because they are rapidly reacting. Before iron get protected, they will get used up with the atmospheric components. Therefore, highly reactive people also not you should not use as bodyguard, because they will fight with the other people going on the road and get killed by themselves from them. But bodyguard has to wait if someone going to attack you, right? Otherwise bodyguard will be getting destroyed before you, right? Okay, so therefore this is very hard section in grade 11 chemistry, the electrochemistry, that chapter 12. But I related this to the grade 10 activity series. Actually these questions I gave here to recall you the activity series, for you to understand the importance of the activity series before you start doing that lesson, grade 11 last few lessons, chapter 12, 13 and 14, right? Okay, question number 91. I'll erase the screen. Question number 91, any volunteers who can give me the answer for the 91? Method of extracting metals from its ore depends on, this is one use of the activity series. The most reactive metal at the upper part of the activity series by electrolysis, least reactive metals by physical method, the moderate reactive metals by thermal reduction. Yes, any volunteers who can give the answer for this question number 91? 91, yes. Depends on the position of the metals in the activity series. Answer 3. Method of extraction depends on the position of the metal in the activity series. Very good, those who replied on chat. Ravin, very good, your answer is correct. Question number 92. 92. Iron contact with a metal which are higher than iron in the activity series. Now again, is linked with the question previous explanation I gave you. So what is the question here? When iron contact with a metal higher than iron in the activity series. Let me say example, zinc or magnesium. When you have magnesium, magnesium is more reactive than iron. So you keep iron nail in contact with magnesium. What will happen? Who will become the anode? I told you, when you are given a pair of metal, who is the anode? How to find the anode easily? The most reactive metal act as anode. What is the most reactive metal out of these two? Iron or magnesium? Magnesium. So magnesium act as anode. And anode, what happened? Number 1, most reactive metal. Number 2, it act as anode. Number 3, it oxidize, giving out electrons. So that is called oxidation. Mg become Mg2 plus. That is called oxidation. So most reactive metal act as anode. Then what will happen to iron? Iron act as what? Cathode. When magnesium act as anode, iron act as cathode. But iron is not going to undergo any reaction here. Near iron nail, who will gain electrons? Oxygen and water. Oxygen and water receive electrons and become 4OH minus. So this is a reduction reaction. This is the anodic reaction. Understood. So who can give me the answer to the question? I need to look at the answers again and tell me. Who will corrode here? Who will corrode here? Iron gets protected by magnesium because magnesium is more powerful. So here you can write iron gets protected from corrosion or rusting. Iron gets protected from rusting because of whom? Due to magnesium. Iron is not undergoing oxidation. Iron is not undergoing corrosion. Why? Iron gets protected as cathode. Iron gets protected as cathode because least reactive metal acts as cathode. Understood? So what is the answer for this? Question number 92. Everyone should be able to give the answer now. Even though you might have not done the lesson, I gave everything possible for you to get the answer. You better keep this in your head. And then electrochemistry also almost half, 50% you might done. I mean, at the end of these questions, you might have done. Right. Question number 93, 92. The answer is Raveen, Imasha, Lakindu gave third answer. Very good. Question number 92. Metal iron behaves as cathode. Very good, excellent. Answer is 3. Right, everyone. Separate write in your writing book. When there's a pair of metal, the most reactive metal acts as anode. The least reactive metal acts as cathode. So it can be iron and magnesium, or it can be iron and zinc, or it can be even zinc and copper. If there's zinc and copper, who is anode? Tell me. If you have zinc rod and a copper rod in contact with each other, who is the anode? Any volunteers? Reply on chat. When you have zinc and copper, grade 10 activity series, who is anode? The most reactive guy acts as anode. Very good. Zinc acts as anode. Imasha, very good. Why zinc is anode? Okay. Zinc is more reactive. Then who is going to lose electrons? Zinc. Who is going to dissolve? Zinc. Who is undergoing oxidation? Zinc. Who sacrifice? Zinc. Who get protected? Copper. Copper is least reactive. Who acts as cathode? Copper. Who is not subjected to rusting? Copper. Corrosion? Copper. Who is subjected to corrosion? Zinc. Most reactive metal dissolve. Most reactive metal sacrifice. Most reactive metal oxidize. Most reactive metal lose electron. Most reactive metal act as anode. Very easy to remember. In the exam, they can change the metals given. That's it. The same concept. Concept won't change, but they can give any pair of metal for this in the exam related to corrosion or related to single displacement or yeah. Right. Question number 93. Which one is the compound that cannot be used to prepare oxygen in the laboratory? Again, grade 10 chemistry. There are 3 gases. You should know the method of production, method of collection, method of identification, properties and uses. There are 5 things you should know about these 3 gases. What are the 3 gases? Oxygen, hydrogen and carbon dioxide. Oxygen, hydrogen and carbon dioxide. Those who are done in 93, you can reply the answer on chat. Right. Oxygen, nitrogen, sorry, not nitrogen, carbon dioxide. Shall I read the screen for the previous one? Right. Cannot be used to prepare oxygen. So here cannot be used, underlined here, cannot be used. Right. To prepare oxygen, we use these chemicals in the laboratory. So what did I tell you earlier? Carbon dioxide, oxygen and hydrogen. These 3 gases, you should know the 5 important things. Number 1, you should know how to make it, how to prepare that in the lab, how to collect that and how to identify. Preparation, collection and identification. These 3 gases. Number 4, you should know the properties of each gas. Properties. And number 5, you should know the uses of each gas. Method of preparation, method of collection, method of identification, method of properties and uses. Each gas. This is again a section where you can get structured essay type questions in the O-level paper. Right, now let's see oxygen production. These are the chemicals we can use. We can use nitrates of group 1. Nitrates of group 1 metals. Group 1 metals, example potassium nitrate. You can use. Except lithium, sodium nitrate. Na nitrates release oxygen on heating. Oxygen is the only gas. In addition, you can use chlorate. Number 2, chlorate. What are the chlorate? Potassium chlorate, KClO3. Sodium chlorate, NaClO3. That also when you are heating, it get decomposed. All this thermal decomposition reaction. oxygen is given out as the only gas. Okay, so you can use nitrates, chlorates. In addition to that, you can use the third chemical that is used to prepare oxygen sample of oxygen in the laboratory, potassium permanganate, that is KMnO4. What is KMnO4? Potassium permanganate. Oxygen is given out as the only gas. Number 4. The fourth chemical substance that is used to prepare a sample of oxygen gas is hydrogen peroxide. Hydrogen peroxide get decomposed to produce oxygen gas in the laboratory. These are the four chemical substances that can be used to prepare oxygen in the laboratory, but not for the mountain climbers or divers or the COVID-19 patients. This is for the experimental purpose oxygen preparation. So this is called the laboratory method. Laboratory method or the experiments, we use these four chemicals. But if you are going to make oxygen gas industrially, industrial methods, that is from you had done grade 11 chapter 3, fractional distillation is used. Fractional distillation is used to prepare oxygen from atmosphere. Number 2, electrolysis of acidic water. Electrolysis also used, that means you can break down water into oxygen and hydrogen gas by passing electricity. So these are the industrial method. From atmospheric air, 21% oxygen, we can get it by fractional distillation. You can cool air and you can get it liquid air you can separate it. Then the other one, electrolysis of water. You can pass electric current through acidic water, then water molecule is broken down, releasing oxygen and hydrogen gas. That is industrial. But now also you get oxygen, everyone is breathing, right? You all breathe in oxygen, you inhale oxygen. From where that oxygen is coming? Not from any of these method. That oxygen is coming from where? Coming from the plants, green plants, that is by photosynthesis. The global oxygen production, globally oxygen is produced by photosynthesis. But indirectly that oxygen is coming out from water. Indirectly that oxygen also from water, because water absorbed to the plant become oxygen gas by photosynthesis. Without water, no oxygen for us to breathe. This is very interesting. If you take this photosynthesis reaction, did you all finish copying down? If not, tell me. Or else you can take a screenshot. Oxygen related things I told now. Oxygen, 4 chemical substances to prepare oxygen in the lab, 2 methods to produce oxygen industrially, and global oxygen production by photosynthesis. Look at the screen, everyone. Now carbon dioxide plus water, photosynthesis reaction. This is also very interesting. Glucose plus oxygen. Now you can see this oxygen coming out in the presence of light. In the cells contain chlorophyll. This oxygen is coming out from, what is the source of oxygen here? From where this oxygen is coming out of the 2 raw metals? From water. Oxygen present in water only coming out from the plant leaves to the atmosphere. That's why I told what? Water is necessary for production of food in the plant. Water is necessary for drinking. For eating you need oxygen. You are not directly water. Why? Indirectly you get the food from water. Without water, no photosynthesis. Then for drinking you need water. Then for breathing also you need water, right? Without water, no oxygen coming out from the plants. Without water. Water absorbed to the plant from the roots only, becoming oxygen later by photosynthesis. That's why the food that you eat, you need water. Right? Water that you drink, it's H2O. Breathe in oxygen, water you need indirectly in the plant leaves by photosynthesis. Carbon dioxide also very important, right? So you can't label this carbon dioxide as a bad gas. Without carbon dioxide, no food in the world. Without carbon dioxide, Earth would be a cold planet. Without carbon dioxide, no global warming, no greenhouse effect. Without greenhouse effect, Earth would be a cold planet. Temperature will be minus. So these things are very important. Pay much attention to these areas. Mostly Excel CO2, therefore CO2 is a bad gas. Without CO2, no food production in the world. Without CO2, you cannot live in this temperature will be very low. These are the important things to remember. Right? Note down these things. So you should know how it is applicable to the environment and the society, the things that you learn. Impact of science on the society and the environment. Okay, now what is the answer? Question number 93. Some of you have already posted the answer on chat. Ravin, Imasha, very good. Answer is 4th. Potassium chloride. Please try the chemical formula. KClO3. Wait. KClO3 can be used. They are asking cannot be used. That is calcium carbonate. Calcium carbonate not to prepare oxygen. That is to prepare carbon dioxide. Any carbonate can be used to prepare what gas? Carbon dioxide gas. Any carbonate can be used to prepare What gas? Carbon dioxide gas. Any carbonate. Look at the screen, everyone. Look at the screen, everyone. Calcium carbonate or calcium bicarbonate, to any bicarbonate or to any carbonate, if you add an acid, what is the gas coming out? Carbon dioxide gas. Look at the screen, everyone. The first one is carbonate. Carbonate and bicarbonate. If you add dilute HCl, the only gas coming out is CO2. To any of this, you can get by adding an acid to carbonate, CO2 is coming out. Therefore, calcium carbonate is used to prepare carbon dioxide gas, not oxygen. So that's why the answer is fourth here. Cannot be used. Answer is fourth. How many of you got the fourth answer? Very good. Ravina, Nimasha, answer is fourth. Very good. Right. The other three can be used. Right. Question number 93. I gave the answer. So at the end of 100 MCQs, you can check how many correct and you are okay with the chemistry for your O level. Right. Question number 94. Look at the screen, everyone. 94. What is the answer? Piece of zinc. 94. A piece of zinc plated iron does not rust when scratched. Why? Because of the bodyguard. Who is the bodyguard? Zinc. Right? If you take a biscuit tin, zinc coated. If it is coated with zinc, even though it's get scratched or this protective layer is removed, no rusting. Why? It's like galvanized. It acts as a protective layer. Therefore, zinc, even though it's get damaged, no rusting. Why? Because zinc acts as the anode and prevent iron getting oxidized. Because zinc is more reactive than iron. Zinc coated tin or container does not undergo corrosion or rusting. Zinc coated can or tin or container is not subjected to rusting. Zinc coated iron object is not subjected to rusting. Is not subjected to rusting. Is that clear? Zinc coated iron object is not subjected to rusting. The reason, what is the reason? Zinc is more reactive than iron. Right? The reason? Because zinc is more reactive than iron, or zinc is above iron in the activity series. Zinc is above iron in the activity series. So yes, question number 94. Any volunteers who can give me the answer? 94th one. Imasha gave the first answer. Very good, Imasha. Anyone else? Others? Zinc position at higher places in the activity series than iron. That's very zinc will not become cathode. Okay, zinc become anode. Iron act as cathode. But that is not the reason for not getting corroded. Right, very good. Ravin, Vilana correct. Tiluni correct. Okay, good. 94 answers first. Question number 95. I'll erase the screen. 95. What is the answer? Right. Rate of reaction increases with the temperature increases. Reason. Okay, any reaction, the rate increases with the temperature. What are the factors affecting the rate of reaction? Temperature, catalyst, concentration, and physical nature of reactants. Physical nature of reactants. So what would be the answer? When the temperature increases, what happens? Molecules are moving fast. Their velocity increase. Then their collisions, or they frequently contact. They frequently contact. Velocity increase. When the velocity increase, what happens? Kinetic energy increase. When the kinetic energy increase, what happens? They collide frequently. Collisions increases. Without coming in contact, no reaction take place. Reacting molecules should come in contact for any reaction to take place. If they are far apart, no reaction. Collisions matters. If collisions occurs at higher speed, at high rate of energy, rate increase. So what is the answer? The number of collisions taking place among the particles increase. That's the reason. Answer is second. Question number 95. The answer is second. Very good. Vilana correct. Imasha correct. Very good. Ravin correct. Lakindu answer is not 3. Concentration and the temperature, two different things. By increasing the temperature, you can't change the concentration. By increasing the temperature, you can't change the concentration unless you evaporate the solvent. Right? What is the answer? Question number 95, the answer is second. Those who got the answer before me, very good. Number 6. Number 96. This cannot be considered as a factor that increases the rate of reaction. Answer is concentration matters, temperature matters, catalyst matters. Answer is 3. The volume of reactant. We don't use the term volume. Instead of volume, we use the term concentration. Question number 96. Very good. Imasha, Ravin and Vilana. Answer is 3. Lakindu, no. Right, you didn't reply. Question number 97. That's a good question. 97. Okay. Can you quickly reply on chat the answer? 97. Is again, you need the activity grade 10. Question number 97. Quickly. You can reply the answer on chat. Who can get the answer before me? So question number 97, most of you have given the answers fourth. Very good. Imasha, Vilana, Ravin, Vetum, Manuga. No, fourth answer Chenul, Ravin, Vilana. Right. Some of you have given the third answer. Jomindu is fourth. Semik also fourth answer. Very good. Manuga and Vetum, third answer. Okay, third or fourth. Let's see. Some of you put third, some of you put fourth. Actually, addition of which the following metal to zinc. Addition of which metal to zinc causes precipitation. Precipitation means single displacement reaction has occurred. Precipitation means a single displacement reaction has taken place. Okay. Zinc chloride. Formation of precipitate. The metal added has to be more reactive than zinc. That is the requirement. Right, everyone? How to decide the answer easily? From the activity series again. The metal added has to be more reactive than zinc. Right? What is the reason? What is the how to get the answer? The metal added should be more reactive. The metal added should be more reactive than zinc in the solution. Or you can write should be above zinc in the activity series. Should be above zinc in the activity series. Should be above zinc in activity series. Is that clear? Who is above zinc? Who is above zinc out of this? Answer is magnesium. Look at the, can you all please write the reaction? Magnesium plus zinc chloride. What happened? Zinc get displaced by magnesium and you get magnesium chloride and zinc gets displaced. So this is called what? A single displacement reaction. What is this called? A single displacement reaction. Single displacement reaction. So the answer is fourth, not third. Answer is fourth. This is called what reaction? Single displacement reaction. Because all the other metals given in the among the answers less reactive than zinc or below zinc. Therefore, no single displacement not possible. Right. Question number 97. I gave the answer. Answer is fourth. Very good. Yomindu, Semika, right. Very good. Tiloni. Next one. Question number 98. 98th MCQ. When a reaction is classified as endothermic. What is the meaning of endothermic? Endothermic means heat is absorbed during the reaction. What is endothermic? Heat is absorbed or energy is absorbed from the surrounding. From surrounding. Therefore, the surrounding temperature goes down. Surrounding temperature, heat is, if heat is absorbed, is endothermic. What is the opposite of endothermic? Exothermic. What is exothermic? Heat is given out. Okay, I'll give one example. If you take water, imagine the temperature 25 Celsius water, H2O. Now you are putting a sample of sodium chloride you dissolve here. So you add here ammonium chloride. Or you can add here ammonium chloride, or you can put here sodium chloride, or you can add even glucose you can dissolve. Sucrose. What happens now? The temperature decreases. Temperature decreases. And 25 degrees Celsius become say 18. Let's see, the temperature become 18. Temperature becomes 18. Right. So then when you dissolve, it becomes Na plus and Cl minus ion in water, but temperature will be dropped. So imagine it becomes say 18 degrees Celsius. Assume. Now what happened? Temperature has decreased. Why? Heat is absorbed from water. Heat is absorbed from water for breaking down the ionic bonds between sodium chloride. In sodium NaCl, to break down the ionic lattice, heat is absorbed from water. To break ionic lattice, ionic bonds in NaCl, heat is absorbed from water. Heat is absorbed from water. Therefore, the temperature of water drops. That's why the surrounding temperature goes down. Test tube and the water is called surrounding. Absorbed from water and surrounding. That's why the temperature drops. So therefore, this is called what? Process. Endothermic process. Temperature decrease. Temperature decrease. Solution cools down. Solution cools down. It is absorbed for this to happen. I'll give one more example. Endothermic reaction. So you can search in the internet. So there's something called cold packs and heat packs. Cold packs and heat packs. Sportsmen, they use this in case of injury. They can't keep a refrigerator or ice bucket or ice bath in the ground. They use containing this. So then when you crush this, the endothermic reaction takes place. So calcium carbonate, this limestone, then to heat, to decompose this, heat is absorbed. Without supply heat, this reaction would not take place. So there the heat is absorbed. You have to supply heat for the reaction to occur. So this reaction absorb heat. Therefore, this is what reaction? Endothermic reaction. Remember, students, you learn grade 10 only 4 types of reactions: single, double, combination, decomposition. But in grade 11, you have 3 different types of reactions other than those 4 grade 10. That is exothermic, endothermic, exothermic, and neutralization reaction. Therefore, in endothermic reaction, heat is absorbed. Then you might ask, so why, if heat is absorbed, why it won't get heated up? That's a simple thing. If someone absorbs, the heat should increase, the temperature should increase, but here the temperature drop. Actually, here we give the temperature not in the system, surrounding temperature has gone down. System, then you might ask, won't NaCl get heated up? That is system? No. NaCl that absorb heat is used for the bond breaking. It is not stored as heat. Absorb heat from the surrounding, not stored as heat in the system. It is used for transferring, it is stored as chemical energy or for breaking the chemical bonds. That's the reason. That's the reason. Heat is absorbed for bond breaking. Bond breaking is endothermic. For breaking bonds, heat is absorbed. When forming bonds, heat is given out. Again, I repeat. For breaking bonds, heat is absorbed. When forming bonds, heat is released. Energy is released. That's also important to understand. So now, if I draw the diagram for this products. So if I take this calcium carbonate thing, look at the screen. During endothermic reaction, temperature decrease, and the products having higher energy. Look at the screen, everyone. In endothermic reaction, products having higher energy than reactants. Either reactants energy, either products energy. HO, you can write E energy. H for enthalpy, E for energy. So here the reactants, calcium carbonate. Then when this becomes this, what happens? This heat is absorbed. Therefore, the products energy goes up. That is how you draw it. Therefore, the products energy greater than reactants. Why? Due to the absorption of heat. Products energy greater than reactants energy in endothermic reaction due to the absorption of heat. Reactants. Products energy is greater than reactants energy in case of endothermic reactions. So what is the answer now? Now at least can you give me the evolution of heat and light? No, that is in exothermic. Okay, when you burn firewood or when you burn LP gas in the kitchen, that is exothermic. This is exothermic. Heat is lost, evolving of heat and light, exothermic. Lighting up a candle. So heat is released to the surrounding. When you burn firewood, a fire, release heat to the surrounding. That is exothermic. No change of energy, that is completely wrong. Out of 1 and 3, what is the answer? Yes, anyone? Yes. Question number 98, what is the answer? Who has more energy, products or reactants? Endothermic means absorb heat or energy stored in the product. So the answer is first one, very good. Energy of products higher than reactants. That's a good question. You can put a star every year. This is introduced to new syllabus after 2016. Every year, all paper they ask a question related to this. Question number 99. I'll read the screen. 99. 99, what is the answer? Incorrect regarding heat changes relevant to the chemical reaction. Yes. 99. If heat is evolved, temperature of the surrounding get decreased. That is wrong. Temperature, if heat is evolved, temperature should increase. That is exothermic, right? If heat is evolved, that is an exothermic reaction. If heat is evolved, it is called exothermic reaction. Then temperature should increase in the surrounding. If heat is evolved, it is called what reaction? An exothermic reaction. Exothermic. If heat is absorbed, temperature of the surrounding get decreased. That is correct. If heat is absorbed, outside temperature drop. That's the answer. They're asking incorrect answer, sir. They're asking incorrect one. We have to be very careful to read the question properly. Look at the screen, everyone. Incorrect statement they ask. So the incorrect one is the first one. Others are correct, right? Energy of the products of an endothermic reaction is lower. That is, energy of products of another lower than that of the energy of the reactant. That is, wait, this is also correct. Wait, we'll forget about this one. We'll tick one by one whether it's true or false. That's the best thing to do. Heat is absorbed during a chemical reaction. Temperature of the surrounding decrease. That is correct. Heat change of a chemical reaction differs according to the physical state. Yes. Energy of the products of endothermic reaction lower. That is, we'll make There will be two answers. Make it higher. Otherwise, the last one also wrong. Then we'll make it correct and the answer will take first one. Okay, then no problem. Answer is first one. Okay, answer is first one. Make a small change. The last one make it higher. Otherwise, there will be two answers. Incorrect one. Right, 99 will take the first answer. Then 100, the last MCQ. Last MCQ. Any volunteers who can give me? That is from grade 10 gases. Gas preparation and identification. Gas preparation and identification. Yes, any volunteers? Last MCQ, 100. Raveen gave the answer, Vilana gave, Tulini gave, Anutmi gave the answer. What about the others? Hurry up. In front of each, you can write what it is. So then you can easily get the answer. Chanul also gave the answer. Very good. Answer is glowing splinter get burned, or that means it's get relights or get rekindled. Answer is oxygen. Okay, I'll put one by one. It should be oxygen. Okay, don't look at the answers. Don't look at the answers. First, predict each gas. Glowing splinter pop sound. You can, I think glowing should be a burning splinter. Anyway, answer is hydrogen. Then red litmus turns blue. Red litmus turns blue by what gas? Basic gas. Red litmus turns blue by basic gas. What is the basic gas in your syllabus? Ammonia NH3. Right, everyone? Basic gas is ammonia. Lime water turns milky, that is carbon dioxide gas. So the answer will be what? Oxygen, hydrogen, ammonia and carbon dioxide. Very good, all of you are correct. Binula, Lakindo, Semika, then who is this? Vasa Fernando, Niti Charul. Very good, all of you are correct. Very good, excellent. So answer is 3, right? Oxygen, hydrogen, ammonia and carbon dioxide. Question number this 100. Answer is 3. Right? Now those who have done this alone at home, please raise the hand. Those who got out of 100 75 or above. I mean those who got the answer before me. How many of you got above 75 for this chemistry 100 MCQs paper? Yes. Raise the hand. Only 5 students raise the hand. Ishan, very good. Binula, Kavindu, Yamasha, Ravin, Anutmi. Very good. About 5 students. Maybe the others you might have not done the paper. You don't know whether because you might have not done the paper before me. That's why. Sometimes you must be okay with this. But anyway, you need to revise chemistry because last few years oral marking. So the chemistry part, there's a drop. The students' performance, the candidates, there's a drop in chemistry section. Then biology and physics. Therefore, you have to pay attention to all 3 areas. You have to put the same weight to go for A pass. Now I will discuss similar I did chemistry and revision completed now. So we'll do physics and biology also like this in upcoming papers. Now I will share the screen for the next paper, the other paper. This is the new paper I have shared with your WhatsApp group, I think through the school. So if you have not got it, please request this from your school teacher, or it is sent to the school principals also to from the school principals or from the school principal or to science sectional head or class teacher. You can get it. If not, you can send a request to the WhatsApp number of the previous paper. Now this is actually covering up to grade 11 second term most probably. 2020, because of COVID, there was a diagnostic paper for the Japura zone students, both English medium and Sinhala medium. So I'll discuss this paper. We won't be able to complete this today. I'll discuss first few MCQs now, and then the rest I will discuss next week. And there are 40 MCQs. Try to do this at home. It's okay if you can't remember, you can refer the notes and do it. But no point of just copying down the answers during the online session, right? If you don't know what's the question even, at least the question, right? First MCQ. Any volunteers who can give me the answer, reply on chat? Yes. Question number 1. Which of the following is a storage polymer? What is the storage polymer out of this? And where it is stored? In which organ? In which group of animals or organisms? Answer is very good. Those who replied on chat. Very good. Imasha, okay, it's in the liver. Very good. Ravin, very good. This glycogen, Imasha correct, channel correct. Very good, excellent. Answer is glycogen. That is the stored form of carbohydrate in animals that is stored in the liver. Right here, glycogen is stored mainly in the liver, right? Put an arrow right. Stored form of carbohydrate. Stored form of carbohydrate in animals. Stored form of carbohydrates in animals. Animals also where liver. Therefore, if you are eating too much carbohydrate, you can get fatty liver sometimes, right? Fatty liver. Liver become fat. The others are a storage one. So in animals, it's glycogen. And one more thing, I wanted to copy down the stored food of. It's glycogen in fungi. Fungi also having glycogen. Fungi. The stored food of fungi also glycogen. Can you please write it? The stored form of food in fungi also glycogen. Stored food in fungi also glycogen. Fungi is glycogen. Right. Question number 2. A medical condition which can rapidly decrease the platelet count is common sense these days. Now it's again rising. Platelet count drops in which disease condition? Yes. Any volunteers? If you know the answer, at least please reply. I'm not forcing you to unmute or to on the video, but anyway, at least you, if you actively participate in this session, reply on chat the answer. If parents are around, check whether your kids are doing the right thing with the device, because your exam is getting close, and get the maximum out of this time. Very good. Ravin, Vinula. Ravin, you get the third answer, right? Viral infection. Okay. Actually, the answer is third, not second. Hemophilia is not clotting of blood. Hemophilia is not clotting of blood. That is not due to the platelet thing. That is a genetic inherited condition. Rapidly decrease the platelet. Viral infection, platelet count goes down. Example, dengue. Dengue is a viral infection. Dengue is caused by virus. Dengue caused by virus. Virus. So viral infection, platelet count going down. Actually, bacterial infection, the neutrophils and all the others will change. Hemophilia, not clotting of blood. Iron deficiency can cause anemia. The most correct answer is 3. Very good. Very good. Yamindu, Vilana, Imasha, right? Ravin, very good. Channel correct. Yeah. Question number 3. Any volunteers? What is the answer for question number 3? The most suitable method to find the components containing the ink of a pen in a ballpoint pen, or ink, the separation of ink or even the pigments you can separate easily by this method. Yes, any volunteers? He is from grade 10, grade chapter 3. Let's see how many of you will get the answer. Very good. Question number 3, the answer is 3. Very good. Hasa, Inuli, Vilana, Binula, Chanul, Masha. Very good. You all are correct. Okay, this one many students replied. Okay. Manug also correct. Very good. Answer is 3. Chromatography. Chromatography. In single we call it Varnaleka Shilpe. So from the word itself you can understand Varnaleka chromatography. So that is if the components of the mixture non-volatile components in the mixture can be separated by this method. Non-volatile components in a mixture can be separated by this method, that is called chromatography method. Question number 4. The blood vessel which contains oxygenated blood. The blood vessel which contains oxygenated blood. This is from heart. In your body, all the arteries contain oxygenated blood except in the pulmonary artery. In our body, all the veins contain deoxygenated blood except in the pulmonary vein. So remember, oxygenated blood is present in pulmonary vein. What is the answer? I don't know how many of you have done the system lesson. Answer is 3. Pulmonary vein. Pulmonary vein. I'll underline the correct answer. Pulmonary vein. Can you please write pulmonary vein carries blood from your lungs to the heart. From your lungs to the heart, who carries blood? Pulmonary. Look at the board, everyone. Look at the screen. Look at the. From your lungs, who carries blood to the left side of your heart? So this is called left atrium or left auricle. This is called pulmonary vein. Pulmonary vein. If you can make a small sketch. Red blood, oxygenated blood reaching from your lungs to the left side of the heart. Then who carries blood towards the lungs from this side? Who carries blood towards the lungs? That is deoxygenated blood or blue blood. Blue blood towards the lungs. Blue blood towards the lungs by whom? By pulmonary artery. This is called pulmonary circulation. What is pulmonary circulation? Circulation of blood through the lungs, called pulmonary circulation. Pulmonary circulation. So this is called pulmonary artery. If you only can make a small scale this diagram, you can easily understand pulmonary artery. But except this artery, all the other arteries of your body contain. Except this artery, all the other arteries contain deoxygenated pulmonary artery. This is pulmonary vein. Except this one, all the other veins contain deoxygenated blood. This is pulmonary vein, okay, not pulmonary artery, pulmonary vein. This side you get pulmonary artery. Pulmonary artery, deoxygenated blood. That is blue blood. That's why I put this one in blue, right? Blue. This side blue blood. Your right side of your heart, blue blood. Left side of your heart, red blood. What is called pulmonary artery. Pulmonary artery contains what? More carbon dioxide, less oxygen. Pulmonary vein contain more oxygen, less carbon dioxide. So the circulation of blood through the lungs called pulmonary circulation. Basically, what are the blood vessels connected to the lungs? Pulmonary artery and pulmonary vein. So this is called right ventricle. This is called RV, right ventricle. Right ventricle. Right ventricle. This is the left ventricle. So left ventricle pumps blood all over the body. Left ventricle pumps blood all over the body. Which blood? Red blood. Red blood. Left ventricle pumps, left side of your heart contain red blood. Right side of your heart contain blue blood. So this side, we call it aorta, that is red blood, oxygenated blood. Red blood contain more oxygen than carbon dioxide. Pumps to the organs of the body. Organs. From the organs again what? From the organs again, blue blood returns to the heart. Organs receive red blood, oxygenated blood, and from the organs, which blood is returned to the heart? Impure blood, or we call it blue blood. That is this one. From the organs, which blood is returned to the heart? That is blue blood. Blue blood. So blue blood. This side blue blood. Organs to the right side upper chamber. Then from right side upper chamber to the right side lower chamber. Then goes to the lungs. So why lungs again send in blood back to the heart? Because lungs cannot provide the necessary pressure. Lungs cannot pressurize blood. After receiving oxygen, blood again flowing back to the heart to get the required pressure to the right side or left side of the heart. Left side of the heart. So this is how the blood gets circulated through your heart and how it is connected to the other. So this is called aorta, aorta, the main blood vessel which takes blood away from the heart, aorta. And this is called from the lower part of the body is inferior and superior vena cava. This is called inferior vena cava. Inferior, that is a vein. It's a vein. Say example, hepatic vein, renal vein, from the kidney renal vein, from the liver hepatic vein. They all takes carbon dioxide or deoxygenated blood back to the heart. Deoxygenated blood back to the heart. So therefore this system lesson also bit important, because you are getting oral paper essay type question number 5 from mostly from the systems. Okay, then so it's almost 10:30. The remaining questions of this paper, I think you didn't get enough time to do this. Yesterday I think most of you all got this. So try to complete all the remaining questions out of until 40 of this paper at home, and I'll give the answers next week with the explanation. Next Wednesday the same time, if the schools are closed on Wednesday. And I will share one more paper before the next class, next lesson. Then you have enough time to do it, right, at home. So therefore now you need to practice papers, right? You can recall the theory by when you're doing the questions like this, right? So get the maximum benefit out of it, and you can definitely improve your marks from C to B or B to A if you are doing practicing questions like this, right? Okay, then we'll stop for today. Have a good day and God bless you. We'll continue the rest from next week, right?